Imagine a weapon so perfect, it doesn't need to explode. It doesn't need radiation, blinding heat, or planet-shattering shockwaves. It just needs to touch you. And the exact moment it does, you, your house, your entire planet, and everything on it become the weapon itself. Like a microscopic, unstoppable cosmic infection. It sounds exactly like a lazy plot for a bad sci-fi space zombie movie. But unfortunately for all of us, this isn't some Hollywood script. This is a real mathematical possibility grounded in the fundamental laws of physics. Welcome to the terrifying, mind-bending reality of strange matter. Arguably the most dangerous and perfectly stable substance in the entire universe. We usually think of black holes as the ultimate universe killers. But black holes just eat things. Strange matter converts them into itself. But to understand how such a nightmare could exist, we first need to visit the most extreme places in existence. The rotting, ultra-dense corpses of giant stars. When a massive star dies, it doesn't just fade away peacefully. It goes out with a spectacular bang, a supernova, leaving behind a core where physics simply breaks down. A neutron star is basically a giant atomic nucleus the size of a city, but with the mass of 1,000,000 Earths. Imagine taking our entire sun and squashing it down in a giant hydraulic press until it neatly fits inside the city limits of London. The gravity here is so intense that the tallest mountains on a neutron star can't be higher than a few millimeters. If you dropped a single gummy bear onto its surface, it would hit with the explosive force of 1,000 nuclear bombs. But we don't care about the surface today. To find the real cosmic horror, we need to go deep inside, down into the very core, where the pressure is so absolute it forces matter into a literal state of panic. Normally, the matter that makes up you and me is made of atoms. And atoms are mostly just empty space. In the center, you have a tiny nucleus made of protons and neutrons, surrounded by a distant cloud of orbiting electrons. But inside a neutron star, gravity is a ruthless dictator. It crushes all this empty space completely out of existence. Electrons are violently smashed into protons, merging together to become even more neutrons. You are left with a star made almost entirely of neutrons, packed together as tightly as physically possible. To survive, they push back against the crushing gravity using a quantum rule called degeneracy pressure. It's basically a fundamental law of the universe that says two identical particles cannot occupy the exact same state at the same time. But at the very center of the star, the pressure is so insane that even this ultimate rule might not be enough to hold back the crush. Because those neutrons aren't solid, unbreakable spheres. They are actually made of something even smaller. Quarks. Meet the quarks, specifically the up and down quarks. They are the fundamental building blocks of almost everything you know. Normally, quarks are extremely shy. They are forever locked inside prisons called protons and neutrons, never allowed to roam free. But at the absolute center of a neutron star, the pressure is so violent that the prison walls simply melt away. Billions of quarks are suddenly free, dissolving into a literal ocean of subatomic particles called quark matter, a cosmic soup. But remember that quantum rule? Two identical particles can't occupy the same state. It's like trying to find a seat in a packed movie theater. When all the lowest energy seats are taken, the remaining quarks are forced into higher and higher energy states. They are miserable. In the core of the star, this translates to an unimaginable buildup of energy. The quarks are literally shaking themselves to pieces. But then, the universe offers a loophole, a way out. The quark realizes it can absorb that excess energy and change its identity. Because a strange quark is a different type of particle, it doesn't have to follow the same seating rules as the up and down quarks. It gets the VIP section. To relieve the immense pressure, half of the quarks in the core rapidly transform into these heavier, weirder, strange quarks. And when you have an equal mix of up, down, and strange quarks, something miraculous happens. They lock into the most perfect state in existence. This is strange matter, the ultimate perfect soup. It cannot be broken, it cannot be burned, and it will never decay. But perfection has a dark side. Because it is so fundamentally stable, anything it touches wants to be perfect too. In a fraction of a second, the entire core and then the entire star is converted. The neutron star is dead. It is now a strange star. And as long as it stays safely inside that star, we are fine. But the universe is not a safe place. Sometimes, in the vast expanse of space, two neutron stars, or in this case, two strange stars, find each other. Locked in a deadly gravitational dance, they spiral closer and closer over millions of years. Faster and faster, until finally they collide in one of the most violent events in the cosmos. A kilonova explosion. The impact is so devastating that it shatters the perfect structure of the star, spewing its guts out into the void. Most of the matter falls into a black hole, but tiny, perfect fragments escape. We call these microscopic droplets strangelets, and they are now flying rogue through the galaxy like perfectly indestructible cosmic stray bullets. A strangelet could be as tiny as a single atom, or as large as a grain of sand. But don't let their small size fool you. Because they are shot out of a supernova-level explosion, they are hurtling through space at a significant fraction of the speed of light. And the most terrifying part? They are completely undetectable. You won't see them coming. They emit no light, they give off no heat, and they have no radiation signature. They are the ultimate cosmic stealth assassins. Now, before you panic, remember that space is mostly just empty space. The gaps between things are unimaginably huge. So the chances of a strangelet actually hitting a solid object are astronomically low. Trillions of them could just sail through the void for all of eternity, never touching a single atom. Harmless, stray bullets in the dark. But when you have billions of these tiny, perfect assassins zipping around the universe for billions of years, eventually, one of them is going to hit the jackpot. Something like a star. When a strangelet enters a solar system, it doesn't care about magnetic fields or solar winds. It plummets straight into the heart of the central star like a heavy stone dropped into an ocean. The intense heat and pressure of a normal sun are basically a gentle, relaxing spa day for a strangelet. It sinks all the way down to the core, where it finally touches normal, happily fusing atoms. And just like inside the neutron star, the fundamental rule of perfection takes over. The strangelet begins eating the star from the inside out, instantly converting every single proton and neutron it touches. From the outside, the star might start to violently flicker or change color as its nuclear engine is devoured. In a matter of days or even hours, the entire massive roaring sun collapses into a sphere of strange matter. It shrinks to something barely the size of an asteroid. For the planets orbiting this star, the end isn't a fiery explosion, because the total mass of the star hasn't actually changed, just its density. The gravity holding the planets stays exactly the same. They don't get sucked in. They aren't vaporized. They just keep spinning on their usual, lonely paths. But without the heat and light of their sun, the system is plunged into absolute, eternal darkness. The oceans freeze solid, the atmospheres collapse into snow, and everything slowly perishes in the extreme cold. A silent, frozen graveyard, orbiting a perfect, invisible purple tombstone. And the strange matter? It just sits there, perfectly stable, forever. But what if one of these stray cosmic bullets didn't hit our sun? What if it was aimed right at us? If a strangelet hit Earth, you might expect a Hollywood-style apocalypse, a giant fiery meteor crashing into a city. But remember, strange matter is unimaginably dense and perfectly smooth. It wouldn't crash, it would pierce. It would punch through our atmosphere and the solid crust like a bullet through wet tissue paper, leaving a microscopic hole. Plummeting straight down with unstoppable momentum, it would settle right into the molten iron core of our planet. And there, in the dense, pressurized center of the Earth, the exact same chain reaction would begin. The infection starts. The iron core turns to strange matter, then the mantle, the purple wave rushing upward towards the surface. On the surface, we wouldn't know what was happening until the very last seconds. Unprecedented earthquakes would shatter the tectonic plates. Massive fissures would open across continents, glowing not with orange magma, but with a terrifying, sickly neon purple light. Cities, oceans, and mountains would simply lose their structural integrity, dissolving into the perfect quantum soup. The entire planet would literally fall out from underneath our feet, collapsing inward at supersonic speeds. In a matter of minutes, the beautiful blue marble we call home would be reduced to a perfectly smooth sphere of strange matter. Because it keeps all of Earth's original mass, the gravity remains exactly the same. But the entire Earth would be compressed down to a sphere roughly the size of a football field. The Moon would continue its lonely orbit around this tiny, perfectly stable purple tomb. We'd be gone, but physics would march on. So, if the universe is potentially full of these invisible, indestructible doomsday bullets, why are you sitting here watching a video instead of being a purple puddle? First, we have to remember the ultimate defense mechanism of the cosmos. Space is absurdly, incomprehensibly huge. Earth isn't just a small target. On a cosmic scale, it's essentially invisible. A strangelet hitting us is mathematically less likely than you winning the lottery every day for a year while being struck by lightning. Second, our solar system has its own built-in force field. The sun constantly blasts out a powerful stream of charged particles, creating a massive protective bubble called the heliosphere. It acts like a cosmic leaf blower, sweeping away interstellar dust and debris. But let's say one gets past the shields and hits you. Surprisingly, you might be completely fine. Remember that atoms are 99.99% empty space. Because a strangelet is so microscopic, it could just shoot through the gaps between your atoms and out the other side without interacting. To start the chain reaction, it has to hit a tiny atomic nucleus perfectly dead center. That's like trying to shoot a housefly with a sniper rifle, while you are both riding on different high-speed bullet trains. And finally, there's a theory that the smallest, microscopic strangelets might not actually be perfectly stable. Without the massive pressure of a star holding them together, they might just slowly evaporate into harmless radiation, long before they ever reach us. A strangelet has to be the exact right size, flying the exact right path to be a threat. So, while strange matter might theoretically be the ultimate unstoppable universe killer, it is incredibly inefficient. The universe is terrifying, but mostly, it's just very, very empty. You are safe. So, the universe is vast, and the odds of a stray cosmic strangelet hitting us are practically zero. You can sleep soundly. That is, of course, assuming the threat actually comes from outer space. What if we don't have to wait for the universe to destroy us? What if we just build the doomsday weapon ourselves? Deep underground, beneath the border of France and Switzerland, lies the Large Hadron Collider, or LHC. It is the most powerful machine ever built by humanity. Its job is to smash subatomic particles together at 99.99% the speed of light. When these particles collide, they generate temperatures hundreds of thousands of times hotter than the core of our sun. For a fleeting fraction of a second, they melt protons down into a tiny droplet of primordial quark soup. And whenever you have a dense soup of free quarks, there is a theoretical, mathematical chance that they could accidentally recombine into a perfectly stable strangelet right here on Earth. If that happened, it wouldn't need to travel across the galaxy. It would just drop through the floor of the machine, sink straight down into the Earth's core, and initiate the exact same apocalyptic chain reaction from the inside out. Wait, are the smartest scientists on Earth casually risking the existence of the entire planet just to see what happens? Well, thankfully, No. The fundamental physics of our accelerators actually protect us from this exact nightmare. When we smash particles together, the resulting fireball of quarks doesn't compress inward like a dying star. It violently expands outward. It expands and cools so incredibly fast that any accidental strange matter would melt back into normal matter before it ever had the chance to stabilize. So we can't accidentally create a strangelet. But what if an advanced civilization, or our future selves, tried to do it on purpose? Could you weaponize perfection? The hardest part wouldn't be making it would be holding it. You can't just put it in a glass jar. Because the glass, the table, and your entire laboratory would instantly be infected. You would have to suspend it in a perfect magnetic vacuum. Imagine a highly advanced, ruthless alien empire. Let's call them the Red Empire. They've built the ultimate stealth missile to end a war. Inside the warhead isn't uranium or even antimatter. It's a tiny, magnetically contained droplet of strange matter, aimed at their worst enemies. They press the big red button. The stealth missile crosses the void of space, entirely undetected by the enemy's standard defense grids. It strikes the enemy homeworld. But there is no massive fireball, no deafening boom, no cinematic shockwave. The weapon simply shatters its magnetic containment, dropping the payload. The strangelet sinks effortlessly to the core, and the slow infection begins. To the people on the surface, life goes on as normal. They might not notice anything is wrong for days, or even weeks. It is the ultimate psychological weapon. A creeping, unstoppable doom that silently hollows out your world from beneath your feet. Eventually, the ground collapses, the oceans vaporize, and the entire enemy planet is reduced to a microscopic purple dot. Flawless victory, right? Well, not exactly. The Red Empire didn't just destroy their enemy. They have just created a permanent, indestructible cosmic hazard right in their own planetary backyard. If a stray asteroid ever hits that tiny, strange star, it will splash thousands of secondary droplets out into the local star system, including straight back at the people who fired the weapon. It is the ultimate, irreversible form of mutually assured destruction. So weaponizing it is a terrible idea. But we don't need evil aliens to fill the universe with strangelets. The universe is doing it naturally. Every single day across the observable universe, countless neutron stars collide, shatter, and spray strange matter into the void. Over billions of years, these collisions have quietly filled the empty spaces of our galaxy with an invisible, indestructible fog of rogue strangelets. But let's look even further ahead. Let's fast forward the cosmic clock to the extreme far future of the universe. As time marches on, galaxies will inevitably crash and merge. More stars will die. More neutron stars will be born. And more of them will collide, churning out an ever-increasing supply of strange matter. It is a one-way street. Eventually, trillions of years from now, star formation will cease entirely. The last normal stars will burn out and fade into darkness. Even the mighty black holes aren't immortal. Over unimaginable eons, they will slowly evaporate away into Hawking radiation until nothing is left. But you know what doesn't evaporate? What doesn't decay or burn out or break apart? Strange matter. Because it sits at the absolute lowest energy state possible, it is immune to the ravages of time. It has achieved total perfection. In physics, the end of the universe is often predicted to be the heat death, a cold, scattered, messy soup of useless particles. But strange matter offers an alternative ending. A universe where all chaotic matter is eventually converted into flawless, unbreakable spheres. No heat, no light, no chemistry, no life. Just an infinite, cold ocean of absolute perfection. Which makes you realize, maybe our messy, unstable, chaotic universe isn't so bad after all. Because without that chaos, we wouldn't be here to worry about it in the first place. But wait, before we write off strange matter as the ultimate cosmic villain, let's flip the script. What if it's actually our greatest salvation? In physics, absolute stability equals extreme energy. If you can force normal matter to convert into strange matter, it releases an absurd amount of power. Forget burning coal, or even nuclear fusion. Strange matter conversion would be the holy grail of thermodynamics. Nearly 100% perfect mass-to-energy conversion. Imagine building a microscopic strange matter reactor. You suspend a tiny strangelet in a magnetic vacuum, just like our hypothetical alien friends did. But instead of a doomsday weapon, it's a power plant. You feed it normal matter, dust, rocks, or even garbage, one atom at a time. As each atom touches the strangelet and converts, it releases a massive burst of pure, clean energy. The ultimate cosmic recycling bin. A single microscopic droplet could power human civilization for thousands of years. But why stop at just endless energy? What about construction? If an advanced civilization could safely manipulate chunks of strange matter without dropping it, they could forge materials with infinite structural integrity. You could build a spaceship out of a strange matter alloy. It would be entirely indestructible. It could fly straight through the center of a star. Or you could build a perfectly rigid Dyson sphere, capturing 100% of a sun's output without ever melting or degrading over billions of years. Strange matter could be the ultimate cheat code to unlocking a Type 3 civilization, allowing humanity to safely conquer the galaxy itself. It sounds like a technological utopia, a perfect future. But there is a painfully obvious catch. You are playing with the ultimate cosmic fire. To harness it, your containment systems must be 100% flawless 100% of the time. If a power grid fails, or a magnetic field glitches, or someone simply trips and drops a wrench, that perfect engine of endless progress instantly drops to the floor and begins eating your entire planet. Oops. So, knowing all of that, is CERN secretly building a doomsday machine right now? Are we in actual danger? It is true that physicists at the Large Hadron Collider smash heavy lead ions together to create quark-gluon plasma. But remember, this primordial soup only exists for an incredibly tiny fraction of a second. Still, back in the late 90s and early 2000s, before the collider even turned on, people genuinely panicked. Lawsuits were actually filed to stop the experiments, fearing that physicists might accidentally brew a strangelet and destroy the world. But physicists quickly stepped in to calm everyone down with some hard, undeniable mathematics. First, any strange matter created in a particle collider would be unimaginably hot. Trillions of degrees hot. Like trying to build an ice cube inside a blazing blast furnace. It would just evaporate instantly before it could stabilize and infect anything. But the ultimate proof of our safety doesn't come from human math. It comes from the sky above us. Nature has its own, infinitely more powerful particle accelerators. They're called cosmic rays. These extremely high-energy particles have been slamming into the Earth and our moon every single second for billions of years, with collision energies millions of times higher than absolutely anything we could ever produce in a lab at CERN. And yet, look up. The moon is still there. It hasn't turned into a giant, dead purple ball of strange matter. So, if the universe hasn't managed to accidentally destroy us with its own massive particle colliders over the last 4 billion years, it's pretty safe to say that our scientists won't do it by accident either. The strange matter apocalypse is canceled. So, if the LHC isn't a doomsday machine, and we aren't building infinite clean energy reactors anytime soon, why do we spend billions of dollars building massive underground rings just to smash atoms together? Because we are trying to look back in time, all the way back to the very beginning of everything. 13.8 billion years ago, mere fractions of a second after the Big Bang, there were no stars, no planets, and no atoms. The entire universe was so incredibly hot and dense that it was basically one giant expanding ocean of quark-gluon plasma. By creating microscopic droplets of this primordial soup in our colliders, physicists are essentially holding tiny pieces of the Big Bang. It allows us to study the absolute fundamental rules of reality. Specifically, something called the strong nuclear force. The strong force is the invisible cosmic glue that binds quarks together to make the protons and neutrons inside every atom. Without it, the positively charged protons in your body would violently repel each other, and you would instantly dissolve into a cloud of particles. It is the strongest force in the universe, yet it only works at distances smaller than an atom. It is weird, and we barely understand it. And those terrifying neutron stars out in deep space? They are the ultimate natural laboratories for this exact physics. We can't visit them, but by listening to the gravitational waves they create when they collide and shatter, we can peer inside their hidden cores and test our theories about how the building blocks of matter behave under ultimate stress. So, while the idea of a microscopic drop of strange matter eating the Earth makes for a fantastic cosmic horror story, the real story is one of human curiosity. A tiny, fragile species trying our absolute best to read the source code of the universe. So, if we aren't building weapons, why even bother researching strange matter? Well, remember the strong nuclear force? Even though it's the strongest force in the universe, it's incredibly hard to study because it only works at incredibly tiny distances. But out there, in the vastness of space, lie the ultimate natural laboratories for studying this exact physics. Neutron stars. By observing how these incredibly dense stars behave and listening to the gravitational ripples they create when they collide, we can test our theories about how the fundamental building blocks of matter behave under the most extreme conditions possible. And particle accelerators like the LHC? They are our way of recreating those extreme conditions right here on Earth, in a controlled, safe environment. By smashing ions together and creating tiny droplets of quark soup, we can study how this primordial matter behaves and learn how the universe evolved from a super hot, dense state right after the Big Bang into the stars and galaxies we see today. So, we aren't trying to build a doomsday device, and we aren't likely to accidentally stumble upon infinite clean energy. We are doing what humans have always done, trying to understand our place in this vast, terrifying, and beautiful universe. It's the same curiosity that makes us look up at the stars on a clear night and wonder, what's out there? Even if the answers we find are sometimes terrifying, the search itself is what makes us who we are. So the next time you hear a scary story about physics experiments destroying the world, remember, the universe has been running those same experiments for billions of years. And we're still here, at least for now. Did this video leave you with a profound, unshakable sense of existential dread about the fragility of the cosmos? Good news! Now you can wear that dread on your sleeve, or hang it on your wall to remind yourself of your cosmic insignificance. Check out our brand new Strange Matter poster. It's printed on high-quality paper, and we promise it is made of 100% normal matter. Or cuddle with our new, totally non-infectious Strangelet plushie. It's incredibly soft and absolutely won't turn your house into a purple puddle. Making these deep dive animations takes thousands of hours of researching, drawing, and animating. Every purchase from our shop directly funds our work, but we literally couldn't do it without the incredible, ongoing support of our Patreons. You guys are our cosmic safety net. If you want to help us create more beautiful cosmic horror, consider joining. You get exclusive behind-the-scenes access, high-res wallpapers,